Imagine you're handed the most complex object ever built by human hands. Now imagine you have to build it while falling, not piece by piece on the ground, not in a factory, not on a blueprint table somewhere in Houston or Moscow, in orbit, in the vacuum of space. Over the course of 22 years, 15 nations, more than 40 assembly flights, a construction crew working in temperatures that swing from negative 157 degrees Celsius to positive 121, sometimes in the same hour. This is not science fiction. This happened. This is the story of the International Space Station, the most expensive, most complex, most ambitious construction project in the history of our species. And it almost didn't survive its first night. The year is 1984. Ronald Reagan stands before Congress and announces that the United States will build a permanently crewed space station within a decade. He called it Freedom. It never got off the ground. For nearly a decade, Freedom existed only in blueprints, politics, and budget hearings. Redesigned 5 times, nearly canceled 3 times. The Cold War was over, but a new challenge had taken its place, one that no rocket could solve alone: money. Then, in 1993, something extraordinary happened. The United States called its former enemy, and Russia picked up the phone. What followed was one of the most unlikely partnerships in human history. The nation that launched Sputnik, that put the first human in space, that had spent 40 years locked in a technological arms race with America, was now going to build something with them, not side by side on the ground, together, in orbit. A Russian Proton rocket sits on the launch pad. It's carrying a module the size of a school bus, a pressurized cylinder packed with fuel tanks, computers, and docking ports. Its name, Zarya, Russian for dawn. It was built by Russia, funded by the United States, and it represented something the world had never seen. A piece of hardware launched by one country, designed to connect to another country's hardware. In space, with no one there to help if something went wrong. When Zarya reached orbit, the entire world held its breath. It worked. 24 days later, the Space Shuttle Endeavour launched from Kennedy Space Center, carrying the second piece of the puzzle. Unity, an American-built connecting node about the size of a large RV, fitted with 6 docking ports that would one day connect to 6 different modules. But first, it had to dock with Zarya. 2 objects, each the size of a small bus, hurtling around Earth at 28,000 kilometers per hour, approaching each other at roughly 28 centimeters per second. One wrong input, one software glitch, one misreading of distance, and the entire program ends before it begins. On December 6th, 1998, it worked. Unity latched on a Zarya, 2 nations, 2 modules, 1 handshake in the sky. The International Space Station had begun, but here's something they don't tell you in the textbooks. That first docking, it nearly ended in disaster. Zarya's batteries were undercharged. 2 of its 6 antennas failed to deploy, and ground controllers in both Houston and Moscow were watching the same data on screens and getting different readings. This was not a simulation anymore. This was 2 countries, 2 languages, 2 mission control centers, and one $150 billion project, all depending on systems that had never been tested together in real conditions. The fact that it worked at all is, to many engineers who were there, something close to a miracle. To understand what assembling the ISS actually required, you have to forget everything you know about construction. On Earth, when you build something, a bridge, a skyscraper, a hospital, gravity works for you. Components rest where you place them. Cranes hold loads in place. Workers stand on scaffolding. Tools don't float away. In orbit, none of that is true. Every bolt turned in space takes 3 times longer than on the ground. Every component must be secured before a spacewalker can move to the next task. Drop a tool, and it's gone, tumbling into the void at 28,000 kilometers per hour. And the entire time, you are falling, continuously. The ISS, every astronaut who ever worked on it, every module, every solar panel, all of it is in a constant state of falling toward Earth while moving fast enough to keep missing it. That is what orbit is, controlled falling, and somehow humans chose to build their most complex creation there. Here's the scale of what was accomplished. 42 assembly flights, shuttles, Soyuz rockets, Progress cargo ships, more than 1,800 hours of spacewalks conducted by astronauts from multiple countries, 420,000 kilograms of hardware launched into orbit, the equivalent of roughly 320 mid-size cars, a structure the size of an American football field, assembled piece by people in space suits with limited oxygen, no gravity, and no margin for error. Let that breathe for a second. The space station is as long as a football field. It was assembled in orbit by humans, by us. The assembly didn't happen all at once. It happened in phases, each flight adding a new organ to a growing body. After Unity and Zarya came Zvezda, the Russian service module that finally made the station livable. Zvezda carried the life support systems, the equipment to scrub carbon dioxide from the air, regulate humidity, control temperature, and provide crew quarters, actual sleeping pods, for the first residents. Because in July 2000, before the station was even fully assembled, the first crew moved in. Expedition 1, Bill Shepard, Yuri Gidzenko, Sergei Krikalev, they arrived on a Russian Soyuz spacecraft and entered a station that, at that point, had no laboratory, no full power, and no guarantee it would be finished. They moved into a construction site, and they called it home. To understand what it really felt like to work on this machine, to be the person on the end of the robotic arm hanging over the darkness, we turned to someone who was actually there. Scott Parazynski is a retired NASA astronaut. He flew on 5 space shuttle missions. He's walked in space 7 times, and he was there for some of the most stressful moments in ISS assembly history. Before the ISS even began final construction, Parazynski was part of the missions to Russia's Mir space station, the aging Soviet-era station that would eventually teach American engineers exactly what not to do and what human beings are truly capable of under pressure. During shuttle dockings with Mir, Parazynski described the approach as one of the most tension-filled moments in spaceflight. 2 massive spacecraft moving at orbital velocity, coming together with the precision of threading a needle while both the needle and the thread are moving at 5 miles per second. There is no slow here, he noted. In space, everything is either working perfectly or it's not working at all, and you have to know, in real time, which one it is. But his most dramatic moment came during the ISS assembly itself. During STS-120 in 2007, Parazynski was tasked with a repair that had never been attempted, and that flight controllers initially weren't sure could be done safely at all. A solar array, one of the massive golden wings that power the ISS, had torn during deployment. The tear was spreading. If it wasn't fixed, the entire power generation capability of that section of the station was at risk. The problem? The damaged array was located at the very end of the station's truss structure, farther than any spacewalker had ventured before. Reaching it required Parazynski to ride Canadarm2, the station's robotic arm, to an area so far from the airlock that if something went wrong, the rescue options were limited, and the torn array was carrying live electrical current. "You're essentially out at the end of a 90-foot pole," Parazynski recalled, holding wire cutters and makeshift surgical staples we'd built the night before, repairing a live electrical system while wearing a spacesuit. He did it. The array was repaired. The power was saved. The ISS continued. Stories like this, repeated across dozens of missions by dozens of astronauts from a dozen nations, are the true architecture of the International Space Station. Not just metal and wire, courage, problem-solving, trust. Over the following years, the ISS grew rapidly. Each shuttle mission added something essential. Think of it like building a human body, except in reverse and in zero gravity. The skeleton, the backbone of the ISS, is the integrated truss structure, a series of massive aluminum and steel segments that stretch across 109 meters, holding the solar arrays and radiators in place. This truss was built in sections, launched on separate missions, and joined together with the precision of a surgeon stitching tissue. The lungs, the life support systems housed in Zvezda and later in the American segment, continuously process the station's atmosphere. They split water into hydrogen and oxygen via electrolysis. They scrub carbon dioxide using chemical cartridges. They monitor every breath the crew takes. The blood, the thermal control system, which is genuinely one of the strangest engineering solutions in human history. In space, there's no air to carry heat away. So the ISS uses ammonia loops, closed circuits of ammonia fluid, to absorb heat from electronics and experiments inside the station, carry it outside through pipes, and radiate it away through massive white panels. Without the ammonia loops, the station would cook itself from the inside within hours. The Brain, Destiny, the American laboratory module launched in 2001, which became the nerve center of ISS science. Inside Destiny, researchers have conducted experiments in biology, physics, material science, and human physiology that simply cannot be done anywhere on Earth. Over 3,000 research investigations have been carried out on the ISS. Data from those experiments have contributed to treatments for cancer, advances in material science, and our understanding of how the human body ages. The muscles, Canadarm2, a robotic arm 17 meters long capable of moving massive modules, repositioning itself by crawling across the outside of the station and holding spacewalking astronauts steady during critical repairs. It was built by Canada, and it may be the single most important tool ever used in the assembly of the station. Without Canadarm2, the final stages of ISS construction would have been, in the words of one NASA engineer, essentially impossible. And finally, the wings, the solar arrays, 8 pairs of golden panels stretching over an acre of total surface area, generating up to 120 kilowatts of power when fully illuminated. They rotate constantly, tracking the sun as the station circles Earth 16 times per day. When you see the ISS pass overhead on a clear night, that flash of brilliant light moving silently across the sky, that's the sun catching those wings. That's us up there. It would be easy to look at the ISS as a feat of engineering, a technical achievement, a very expensive piece of infrastructure. But that would be missing the point entirely. The International Space Station was built by a partnership that 40 years earlier would have been considered literally impossible. The United States and the Soviet Union spent decades pointing nuclear weapons at each other. They raced to the moon as a proxy war fought in silence. They built separate space stations, launched separate cosmonauts and astronauts, and refused to share data that could have benefited both programs. And then they decided to build something together. Not because it was easy, because it was necessary. 15 nations contributed to the ISS. The hardware is a mix of Russian, American, European, Japanese, and Canadian components. The crew at any given moment might include a Russian cosmonaut, an American astronaut, a Japanese astronaut, and a European astronaut, all living in a space the size of a 6-bedroom house, sharing meals, sharing oxygen, sharing a toilet. In orbit, there are no flags on the outside of the station. There are no border checkpoints between the Russian segment and the American segment. There is just the station and the people inside it, and the thin blue line of Earth's atmosphere below, a reminder of how fragile and how precious the only home our species has ever known truly is. Former astronauts who've lived aboard the ISS often describe the same experience when they look out from the cupola, the 7-windowed observation module that offers a panoramic view of Earth below. The borders disappear. The conflicts that seem so enormous from the ground look, from 400 kilometers up, like lines someone drew on a map. And what remains is a planet. Brilliant, blue, impossibly beautiful, and very, very small. That is what the ISS was built to show us. But the ISS has an expiration date. The station was designed to operate until 2024. NASA has extended that to 2030. But eventually, probably sometime in the early 2030s, the decision will be made to end operations. And when that day comes, the ISS will not be disassembled and brought home. It will be guided downward into Earth's atmosphere, where it will burn 420,000 kilograms of steel, aluminum, and wire, 22 years of assembly, more than 1,800 hours of spacewalks. The collective engineering genius of 15 nations burned up over the South Pacific. There is something both heartbreaking and strangely perfect about that ending. The station that began as 2 modules, 2 old rivals reaching across the void to shake hands, will end as light. A streak of fire across the ocean sky, witnessed by no one, mourned by everyone who understood what it meant. But before that happens, Private stations are being planned. NASA is funding commercial replacements. SpaceX, Axiom Space, and others are designing the next generation of orbital platforms. Smaller, cheaper, more flexible. The ISS doesn't end the story of humans in space, it begins it. The International Space Station is many things. It is an engineering marvel. 109 meters wide, assembled across 42 missions over more than 2 decades by humans in spacesuits working at the edge of what's physically possible. It is a laboratory, host to over 3,000 scientific investigations that have changed our understanding of biology, physics, and the human body. It is a political miracle, proof that nations who spent decades preparing to destroy each other are also capable of building something that has never existed before. And it is a home for the 270 people from 20 countries who have lived there, floating above the clouds, eating rehydrated food, sleeping in sleeping bags velcroed to walls, watching 16 sunrises a day. It was simply where they lived, where they worked, where they looked out a window and remembered why they came. The ISS will burn. Everything humans build eventually does, but the knowledge it gave us, the cooperation it proved was possible, and the vision it offered of a species that could set aside its wars long enough to build something extraordinary that will not burn. That stays with us. That is ours to keep. If this story left you with chills, you're not alone. The ISS is one of those topics where the more you learn, the more incredible it becomes. So here's what I want you to do right now. Drop a comment below. Tell me, which part of this story shocked you the most? Was it the electrical repair Scott Parazynski pulled off? The fact that the whole thing nearly collapsed in its first week, or just the sheer scale of 420,000 kilograms assembled in orbit? I read every single comment. Let me know. And if you're new here, this channel is where we take the most jaw-dropping stories in science and space and give them the treatment they deserve. Subscribe so you don't miss what's coming next. Because the next video, it involves a cosmonaut, a fire, and the moment the ISS almost became a coffin. You'll want to be here for that. Until then, keep looking up.